And all right, perfect. We're live streaming. All right. Thank you everyone for joining. I know I'm saying this again, but this is for folks who are joining us live on YouTube. I'm super excited to host. I'm going to make sure this is not an open tab. And I'm super excited to have Akira come on to Mint Bean and talk about a very relevant subject and to learn more about cybersecurity from a developer's perspective. And I'm going to let her introduce herself. Take it
All
away,
right.
Akira.
All right, let's do it. Hi everyone. I'm Akira. I am a software developer. I've been in the field for just a little bit over 2 years. So I'm somewhat relatively new, but I have enough airtime in the field to be able to somewhat have a frame of reference to understand kind of what's going on, but let's not get too far ahead of ourselves. I still am learning every single day. I am currently working as a developer relations in a company called Fusion Auth. We're a very small startup here in Denver, Colorado, and we focus mainly on authentication and authorization, and also identity and access management. So let's go ahead and get started. I'm going to do, first off, I'm going to paste a vocab sheet, as it were, in the chat. And it's just going to be, something that you can reference throughout this talk. One thing about cybersecurity in general is that there is a lot of jargon and maybe little tiny pieces here and there that don't necessarily come up in day-to-day development environments. So I just kind of want you guys to be able to reference that. If you have questions, please feel free to put them in the chat, since this is a little bit of a longer talk. I don't necessarily want to stop too much, but we are going to have some time at the end to go over some questions. Okay, so yeah, just really reiterate, I'm Akira, work at Fusion Auth. And again, the whole purpose of this talk today, and just kind of my mission in general right now, is I really want to educate front-end devs and all devs, but especially front-end devs, on just cybersecurity best practices. And bridge that gap between, of course, the sort of siloed cyber people and the siloed dev people, so they can have just more communication and produce more secure software. Okay, so here's what we're going to cover today. First off, we're going to do an overview, a state of the union of cybersecurity right now, and how it pertains to you. And then we'll go into some common weaknesses in JavaScript apps and how to fix them. For what it's worth, we're not going to go over every single weakness that a JavaScript app can have, and we won't cover all these super in depth. I think that even one of these weaknesses could be its own hour-long talk, but I at least, again, want to give you some frame of reference to at least be able to understand a little bit more about the world of it and be able to look into it more for yourself. And at the end, we're going to have about 10 minutes for Q&A. All right, so this is a fantastic infographic of the current sort of state of data breaches in the past, let's see, from 2017 to 2021. As you can see, Facebook is sort of the kind of consistent, what do I call it? They don't perpetrate the data breaches, but they have the most issues with it for at least the past couple of years. Microsoft is huge, Oxydata is huge, and all these also little tiny companies here and there that maybe you've never heard of. These are companies that have gotten hacked into and had their data just snagged. So why does that matter? Well, first off, it matters because, of course, people's sensitive data, their addresses and their search histories and their health histories, any kind of things, are being exposed to the public, which is not good. But the reason it matters to you as a developer is that these data breaches cost a lot of money. On average, I think something like $5 million per data breach for a small data breach is what the company has to pay to fix it, and also to deal with the legal issues that come with it. It's cost lost revenue, because of course you're going to lose some consumers' trust. They're going to be well, I don't want to use your product because you keep getting breached and I don't think I trust you. So as devs, it's not going to be necessarily something that in your development lifecycle, especially if you're early on in your career, is going to be emphasized that much, because security doesn't make you money, right? If you choose to, validate form fields and all this stuff, in your code, that's cool, but it's not initially impacting the bottom line, but the bottom line is very much impacted afterward once a breach happens. So it's just good to know. There's also, this is kind of something I want to break down for you guys as well. this is the 7 layers of like it's called an OSI model, and it's like an application security model and what each of these layers sort of deal with. And it goes all the way from the physical structure of an application, like the actual like coaxial cable or the fiber, the copper wire that they're laying down in data centers, all the way up to the end user layer. Each one of these layers in between have different protocols. So the protocol is essentially a way for data to be transmitted through the internet and how that's done. They have different ways to communicate the data, and they also have different vulnerabilities for each one of these like tools in each layer, and each tool can be thousands and thousands of lines of code. So that's just something that's like a little bit scary. I don't mean to freak everybody out, but it is like important, right? It's not just a small thing. It's pretty huge. And also why cybersecurity is such a huge industry right now. Let's go on. This is something I want to talk about. This is a security breach that was in the actual SSL communication like protocol, like the way the SSL was written, that was essentially, it was shipped to like every single server, like an AWS server or DigitalOcean server. And you could go through SSL using the security vulnerability and just read the data off of these servers, like just arbitrarily just read the data. That's not great. And the thing that's a little bit freaky about it is that it was in the SSL library for 3 years and no one knew about it. And SSL is hugely used. So these are like kind of a big deal, right? So that's just something to know. State of the Union. And this is very ongoing. This is very constant. So if you do find this interesting, you want to get into it, there's a ton of work. There's plenty to do. All right. So you as a developer though, what do you need to consider? Well, first off, the first thing you should think of is how much security do you need in your app? If you are developing a like recipe app where someone is just reading recipes on your website and they don't have to log in, you're not tracking them with cookies necessarily, like they don't need to be sending anything back to a server, then you maybe don't need a lot of security. But if you're a bank, you need way more security than that. And even like even just basic apps now that have authentication and authorization, aka log in and log out, you're still going to need a pretty good amount of security inside of that. You can't just like send a plain text password and like store it on a server and like think you'll be fine. Like you have to hash your passwords and all kinds of other stuff. The second thing to think about is what is the app supposed to do, and how is the app supposed to behave? And inside of choosing those things, right, like choosing your features that you're going to develop and like how your app is going to go about implementing those features, you can then start developing with security in mind from jump, right, from get-go. So maybe there's one kind of sloppy way to do something, but if there's another way that's a little cleaner, maybe you're going to use TDD, so that's test-driven development, or at least you're going to be writing unit tests more often, and then also like taking things you learned from me today and things you learned from other people and writing in a more secure fashion, you're going to have a lot less vulnerabilities, and you're sort of shifting all of the problems to the left, right? So you're not like coming up like 2 months in your development cycle and going, oh crap, like this is really bad, and now I have a breach, and now I'm going to get fired, and we don't want that. The last thing is the framework that you're going to use, such as React or Vue or Angular. A lot of those do have a lot of built-in security sort of safeguards, right? And the most important thing though is that you understand what those safeguards do. Like, why are they there? Like, why does React maybe automatically validate all my forms or something along those lines? And also, do you understand enough about it to be able to use it correctly? You'll see later, especially in like the React kind of gotchas, that people will use React security features, but they won't use it right. And then they'll actually end up like exposing the data in ways that it's sort of counterproductive. So good to know. OWASP, we'll just do a call out really quick here. That's a fantastic nonprofit for cybersecurity. They have cheat sheets. They're awesome, like how to guard against cross-site scripting and CSRF and all this other stuff. And they're super extensive. They're very, very useful. It's like MDN, but for cybersecurity. Okay, I want you to think about an app and what are the things you could put into your app, right? So you can have request headers, you can have cookies, you can have little form fields, you can have URL paths, other websites can like run functionality in your website. Anything that you can put into your app, any sort of way that an app can have input in it is a security vulnerability. So that's also something to think about. Is like, okay, if I'm going to have like an app that has like, form field, that's actually right away, boom, that's a big signal. Like I need to be watching out for vulnerabilities here. Okay, so let's now go into some nuts and bolts of just common threats. So the first one that I want to talk about that Navi actually mentioned earlier is command injection, or otherwise known as SQL injection. So SQL injection is literally, you can go to a website and there's a form field and you can write either like a URL that has like a SQL query at the end of it, or you can sometimes even just write raw SQL that doesn't work as well. And that will run on the app's database. So that's not so good, right? So as Navi was saying, like her friend got hacked into an airline while he was in the air, just through a simple SQL injection. In this little example here, this URL that this hacker would put into like a form field would turn and would compile into SQL that would run on their server. And the SQL itself would be like, okay, just take the item name and the item description from an items column where the item number is 999 or 1 equals 1. Since 1 is always equal to 1, that's always true. It's going to give you back all the item names and item descriptions, which is like, okay, well, like maybe that's not a big deal. It's just like a bunch of item names and descriptions. Like who cares? It's already on the website anyway. But what if that was like username and passwords? And you did not have ways to guard against SQL injection. And then all of a sudden this hacker goes in and just makes some kind of like arbitrary, like true statement. Like if something is always true, then give me all these username and passwords, and boom, like that's like a free for all. So that's not great. All right. So how are we going to guard against that? So first off, the best thing you can do is validate all the user input on the server side. So like when you send a request to the server, you should write some code, like maybe on your server side part of your app, that's like, okay, is this user input legit? Is this a request that is okay? And also on the front end form side as well, so that you can't maybe necessarily like be injecting like literally like raw SQL. Also, eval is not very good to use. Eval is a built-in JavaScript method. And if you are going to use that, you should validate the user input. And you might say, well, I don't use eval. Like, I don't even know what that is necessarily, but eval is used like underneath the hood with set timeout, set interval, and also function. So like the set timeout, you should be able to validate the user input to anything that set timeout runs. I like to joke, it's like early days of COVID and your form fields or restaurant, sanitize everything. Okay. Let's talk a little bit about cross-site scripting. So cross-site scripting runs malicious JavaScript code in a victim's browser, usually by injecting it into form fields or a malicious link. The thing about you should understand about cross-site scripting as well is that it can steal your cookies and your sessions IDs, and then it will log in as you, quote unquote, to other sites and steal your stuff. Cross-site scripting, it's not something that isn't going to happen to you. Like the bigger your app, the more vulnerable it will be to cross-site scripting. So it's kind of not a matter of if, but when. The good news is that, again, a lot of these front-end frameworks like React have like built-in like cross-site scripting, like safeguards, but again, you need to understand how they work and how to use them. So, okay, how are we gonna guard against cross-site scripting? Like just from jump, sanitize your user inputs, leverage your frameworks. You can also set appropriate headers. So there's actually some built-in headers that will guard against cross-site scripting. Two examples are x-xss-protection, and then the other one. Also, there is something called a content security policy that you can leverage. Essentially what that is, it's an HTTP response header that allows you to put certain things on an access list. So it can say, okay, I only want you to accept script sources from like myself, like a self-referential app. And then maybe like you have like some pictures or whatever on a CDN that you want to allow on your website, then it can get from there. So for example, let's look at like this down here. If you have like the first two lines, script source, CDN example, okay, well, that's fine because in my content security policy, that URL was allowed. And then of course the second line would work because it's self-referential. So like, app.js. And the third one, if there's like a script source and in your HTML and it's, evilcorp.cam, then it's like, oh, no, sorry. Like I don't recognize that. That's not on my allow list. So I'm not going to run that. Okay. I want to do story time. So the cross-site request forgery is still, even to me, like a little bit confusing. It's like a branch of cross-site scripting. So here's kind of like how I want to explain how it works. So attacker makes a link in an email. First off, they make an email and they like spoof it to look like Bank of America or something, right? So like has like a similar logo, and maybe it comes from like somehow they maybe hacked like a someone else's email to send it to you, so it made past your spam or whatever. And on the email, it's like, do you have suspicious activity? You should like click on this link. And if you look at the link a little closer, it's like Bank of America, not America. And but you think, because humans are emotional, right? And we trust when we shouldn't, unfortunately. You think like, oh no, like I really need to click on this link, make sure it's all okay. Because you've already logged in to the real Bank of America somewhere else on your browser, that cookie from that site is passed to the attacker, and the attacker can then use that cookie to authenticate back to the real bank, to the actual bank server, and take all your money, which is kind of sad. That's not a lot of fun. So the reason this exists too is because of something called the same origin policy on browsers. So the same origin policy limits how one website or a tab can interact with other websites open in the same browser, right? So if I have like one browser and I have Facebook on one side and like Amazon on another side and then like my bank on another tab, this lets you, this dictates how those websites can interact with each other. You can actually write from one to another. So like, so if you have like from HTTP my site to HTTPS some other site, that's okay. You can embed things from one origin into another, like such as CSS files, but you can't read from one origin onto another site. However, cookies can be sent from one site to another to do implicit authentication. So that's again where that can be dangerous, because if you are writing from one site to another, some attacker can come and take that cookie and use that to prove that they are you. This is just like a little example of that. This is from MDN, which I love. So this is like showing like what would be the same origin and then what would be a cross origin. So as you can see here, like the first two are the same origin. The file path is different, but like the actual the protocol is the same. So it's HTTP, which is fine. And then the next one would be HTTPS, so it'd be different, and so on and so forth. So this again just kind of dictates what you can read and write to on your browser windows. Let's talk about fixing it. So again, your framework might have built-in CSRF functionality. We call it CSRF instead of cross-site request forgery, and use it correctly. Another thing you can do is set a non-static header at each request, and then check that header is there on the server side. So that's just a good way to, again, like make sure that you're passing requests to and from that aren't just like with regular headers. Like you can use some non-standard ones just to add another layer of validation. Don't use implicit authentication with cookies. That's a big deal. So if you're just using cookies to authenticate who you are from one service to another, that may not be so good, because someone can take that cookie pretty easily. Another thing you can do is with all your requests, you can include a random token. And then you would not use cookies to transmit that token. You can store those, for example, in a JWT or a JSON Web Token. And you can also add tokens to requests that mutate the state of your app and validate those tokens on the server side. This is a little example of like a way to send a CSRF token, like inside of a form. You can also do this in the header. It's like a little bit better to do it in the header, but here we are. So you see here, like the form action would be like, okay, I want you to do something and do it with a post method. And then inside of it, have a CSRF token that is hidden, that is then validated on the server side. Let's see here. All right, oops. Okay, well, let's talk about session management. So session management is essentially saying, who are you and what are you allowed to access? Please don't make your own authentication or trying to manage your own sessions. It's really hard, and there's so many authentication protocols that you're going to get really confused, and it's really expensive if you don't do it right. However, If you do want to try to make it, you don't want to listen to me, that's fine. Like, you don't have to listen to me, right? I'm just some lady like talking to you. It's okay. But if you decide to try to make your own auth to understand the auth flow, that's okay. But you should implement the following. At the very least, don't expose your session tokens in the URL. That means in your URL path, don't like somehow make it so that the session tokens are just displayed. Like, please just hide them in a JWT. Give your token an expiration time. Use HTTPS protocol for sending tokens to and from. And if you have a successful login, make a new token, right? So recreate it. There's also two things you should use. These are authentication protocols. One is called OAuth 2, and the other one is called SAML. You should use OAuth 2 or SAML. I just think OAuth 2 is like better, but that's just a personal preference. Also, just because I understand it a little bit more. So of course, like internal human bias, like I'm like, oh, like that's just clearly better. But you should at least use some of these flows. Let's talk a little bit about OAuth itself, right? There's different types of OAuth. This is like OAuth with an implicit code flow. It's very depreciated. Don't use it. I'm going to post on my slides later too, so you can like actually look at like how this works. But I tried to use like an example of like a person trying to get their paycheck from a boss, because otherwise it's kind of confusing. So if it's an implicit code flow, like the user would go to the client and say, hey, I want this resource, or in this case, this person says, I want my paycheck. And then the client would say, okay, you need an access token. So you need to go to the auth server and get that access token. So already, if you're trying to write this yourself, it's like, oh God, now I got to write an auth server. Like, yeah, you do. And you need to figure out how to pass access tokens back and forth. The auth server then gives the access token to the client, which then gives it to the server. And the server says, oh, okay, yep, that looks legit. Let me go get your stuff. And it will, give you back your resource. From a human perspective, when I first saw this, I was like, that seems like that would be secure enough, right? Because like that's a lot of steps. However, that access token, it's very easy to steal it, or spoof it, and then just pretend that you are who you say you are, and then get all these resources. The next way to do it is OAuth with authorization flow. This is kind of like a little bit more secure way of handling this. And I won't go through it all right now because I don't think we have enough time. But again, you can look at this on the slides. But the last thing I want to mention that is the best way to do it is OAuth with an authorization flow on Pixie. And this is essentially a very, very like complicated way to pass these authorization codes and access tokens back and forth, including like passing these tokens with a secret note that like the auth server can decode. It's a little bit confusing, and again, I'll let you guys like kind of look at this later on. But I guess TLDR, since there is so many steps to this, if you're trying to write a production level app with your own auth, like you're gonna mess up, and it's gonna be really hard. So please just use an external service to do that. Okay. This is a fix it in general. Update your dependencies. I don't know if y'all have ever run, like, when you run when you download npm packages, or you open up your terminal, you open up your console window and there's just like tons of warnings. That's okay, but not really, right? Like if your app depends, you're a JavaScript developer, like your app is going to depend on other apps, right? Like maybe your app is like a grain of sand, and your code is like the grain of sand, and then all the dependencies that you have to have in order for your app to run is the beach, right? Those dependencies are going to be depreciated. They're going to have vulnerabilities. Always be updating your dependencies. Audit them. There's really cool tools that you can use for that I'll mention here at the end. That you can actually plug in your app and be like, okay, like what sections of my dependencies might be kind of shady. Definitely just make it a very regular habit to update your npm packages. If you're totally new to the world of JavaScript and maybe don't have a lot of reference for any of this stuff aside from like, oh, okay, I think I use npm packages, I use like a library to do something. That's like the biggest thing I want you to take away from this is like, this is like a bare bones good thing to do. Okay. Let's go over a couple of like gotchas. So React, there are a couple things that people have done quite often that we definitely don't want to do. The first one is to build a component based on user input. Sometimes people think like, oh, like maybe if the user inputs something specific to them, I can like make a component based on their information. Don't do that, because obviously people can just write super malicious code, and then your React app is of course executing that. There's a dangerously set inner HTML tool in React. It's like a built-in function, and that is very explicitly named dangerously set inner HTML because it really wants you to be specific on how you use it. However, sometimes people will see that and be like, oh, if I just use this built-in function, then I can set my inner HTML and it will just take care of it. But if you don't use it correctly, it's actually going to expose your app to a lot of vulnerabilities. So that's kind of going back to the whole thing of like, if you're using a framework, like just understand what the tools that you're using do. Using anchor tags in conjunction with allowing a user to inject JavaScript into form fields, like don't do that. And then lastly, the Redux library had this vulnerability inside of it for a long time, and we saw that earlier with like OpenSSL, right? That can just happen. What that will do is it will like stringify some JSON on the page load, and that is just, it's a mess. You don't want to do that. And what it's worth calling out that this way to do this on page load function was in the docs for a really long time. And so a lot of developers used it, and I still don't even know if it's been fixed in the docs, to be honest. So this is just something to know. Be careful when you're using external tools. Oops. Oh, okay. Yeah, I had one for Vue, but I guess that slide got deleted. I'm so sorry. Okay. Well, here we are. Then let me call out Angular really quick too. Angular is great. Angular has a really good way of like training their devs to use their framework in a very secure manner. So if you do use Angular, I would definitely recommend you check out like their resources. They do have like a whole like cheat sheet that you can go to. Looks like, I'm so sorry, it looks like that slide just got totally deleted by accident, but here we are. Yeah. And then at the very end here, of course, we have some further learning that you can do, some extra resources. And yeah, that's all I have, but I definitely want to take a little time, probably about 10 minutes or so, to go over some questions, maybe some nuts and bolts. We can look at like a couple examples together if you guys want. Yeah, so I'll open up the floor, and if you want to unmute yourself or ask questions in the chat, that is totally fine.
Kira, I have a question. Will you give us access to these slides post your talk?
Yeah, of course.
Awesome.
And then, yeah, Cameron brought up a really good point. I was like, my brain went blank. I was like, oh my God, what is the command? NPM audit is really good for knowing about your security vulnerabilities. So going back to like making sure that your NPM packages are in good shape. Let's see if there's any other questions in the chat right now.
I had a question about that last little React gotcha.
Yeah.
Section, because I was right there with you the whole time with all the speed. You said don't build a component based on user input, but how do you build a form then? In your opinion, how do you build a form safely? Even though, so that does require user input, but then they could front page.
Yeah, totally. That's a really good question. So I guess what I'm trying to say inside of like don't build a component based on user input is like literally don't write code that would take like anything that someone puts into a form and then create a component inside of your React app based on that input. So for building a form safely though, I mean, again, React has some pretty good built-ins for like making sure that all of your form fields and stuff are validated. But the base thing I would do is use form validation. Make sure that you can't like put in like script tags in your form. Like a way to just check that is like if anyone is using angle brackets, like sorry, like you can't put that in because that will just run some JavaScript, like potentially run JavaScript code on your server. And also do form validation on the server side as well. So if for some reason on the front end, someone was able to like write something that's a little bit shady, do a double check on the back end, like, okay, like this person just tried to send me something in a form field with, again, like a script tag or something along those lines.
Perfect. Thank you.
Yeah, for sure.
I got a question.
Yeah.
So I know you heard about the hack in Expedia a couple of years ago.
Yes, I did.
So that was an error that a developer made that was that they decided not to upgrade to one of their dependencies. So the thing is that when you sometimes update your dependencies, it could break the app. And you have to find the bug, find which package is not cooperating and whatnot. So how you go about doing that?
That's a good question. Like, so I just want to make sure I'm understanding like what you're asking. Like, so you're asking like, what if you have a dependency that is not necessarily secure, but if you don't use it, your app is going to break? Like, what do you do?
Yes, sometimes when you upgrade, it breaks the whole app, and then you have to figure out where and when.
Totally. That's a really good question. I think that depends on your use case, right? Like, so if you upgrade a dependency and all of a sudden your app doesn't work, I think the best thing to do would be to, and this is just personal opinion, I'm sure other people have like better ways of approaching this or different ways. I would go look at their docs, right? And just like look at like, what changed in their most recent patch. And be like, okay, like, and just try to isolate like the things that aren't playing well together anymore. If you have like a good, if that dependency also has maybe like a pretty active like developer community, you can maybe post like an issue, or if they have like any kind of support, you can be like, hey, like, I was using your dependency in such and such a way, and then you release this patch and now my app doesn't work. So that might be good for their devs to know as well. But I don't think that there's necessarily like a giant catch-all answer to that. I think it really would just depend.
Yeah, sure. Thank you. I'm just starting off, but picture you.
For sure. All right. Any other questions? Okay, Don says, you said don't build your own OAuth, but use a package. What are the big reasons? What do you get with a package that you can't do yourself? Don, that's a really good question. So kind of like how I was trying to show in some of these like graphs and flows, if you're going to implement OAuth 2 correctly, there are a lot of steps and it's very, very complex. So with the more complex something gets, the bigger, of course, your room for error. And if you're trying to build an app and trying to build OAuth, at some point there's gonna be some kind of trade-off, right? Either your OAuth is gonna be poorly implemented because you don't have enough time or expertise to handle it, or your app itself is going to suffer because you don't have enough time to dedicate to your app because you're spending all your time on OAuth. So when you use an outside service or a package or anything like that, what you essentially get is you get like people who are dedicated to this very, very complicated system that's all they do, right? The company I work for, FusionAuth, like has a free like developer edition that you can use up to however many users you want, and just lets you kind of integrate authentication and authorization within OAuth 2, without having to spend so many man hours on it. And I think even if you're an amazing rockstar developer, you're just going to run out of time. So it's a good way to just outsource the tough stuff to someone else. I would almost sort of liken it to in the olden days, if you like wanted to have your own servers or something like for your app to serve up your app, sure, but then you got to buy all this equipment, you got to run all these servers, you got to have all this space around. And nowadays people just, they offload it to the cloud. Like enterprise people do that all the time. Like people run their software that they sell on Amazon servers, right? It's just about outsourcing that and saving yourself a lot of time and headache. I guess the last thing I would say on that too is that, like I said at the beginning, if you implement OAuth incorrectly, there's going to be problems. It's going to cost your company a lot of money. So, yeah. Okay, let's do maybe like 2 more questions. Or yeah, if anyone has like 1 or 2 more. Or maybe it was like the most clear thing in the world and you have no questions and you're a genius now. That'd be amazing too. Okay. All right. Okay, well, if no one has any questions, oh, John just wrote one. Have you heard of formal verification of software? I'd love to learn more about this. I have not heard of that. Formal verification of software. No, is that, does anybody know what that is or have a hunch on that? Is that like where you can get maybe like a seal of approval or something? Like it's standardized, this is a secure piece of software?
It's like a way to make software as provable as a theorem or a proof. So like, but I'm trying to learn how to do it, and it's like if you go to the Wikipedia article, it's very interesting. But I'm just trying to learn more about it.
That's super cool. I'll check that out. All right. Okay. If that's all the questions we have for now, then yeah, I'll say goodbye. I'm going to post the slides in the Mintbean Discord. And Navi, I'll also get the slides too. If you want to put them on the YouTube or anything like that, feel free. And yeah, if you have any more questions for me, you can find me in the Mintbean Discord. I'm there all the time. And yeah, thanks everyone for coming. This was my first talk in this job about cybersecurity ever. So I just really appreciate everyone being here. And if you have feedback too, or anything that you want to know more about, or you're like, wow, that was actually totally wrong, like I would want to hear it because I want to get better. So thank you.
No, that was great. Thank you so much, Akira. I kind of wanted the questions to roll in. That's why I was a little bit quieter. I think you did a great job in covering a very, very complex subject. I think that it's like you started the talk by saying that the two worlds of cybersecurity and development are just so separate and they don't talk to each other. And it's funny, you would think, I remember like when I started talking to my really good friend, I didn't know that I didn't even know actually that there was a whole specialty for cybersecurity and how deep that field goes. And then I didn't know that cybersecurity specialists actually don't know development, and that like it's like a separation. And you also touched on like some really interesting subjects, like the fact that a lot of companies, big, small, medium, they all sort of look at cybersecurity almost as a cost center. And I think the conversation is changing. I really do. I really think with all the vulnerabilities that you mentioned, with like you said, that library had that vulnerability for 3 years. And just like everything that you kind of hear with the larger players, like I think Equifax a couple of years ago, and then of course Facebook happens to be the biggest culprit, or at least the loudest one. So yeah, I think that more companies are starting to invest more in cybersecurity, which is really nice as a user. And I think that and more so for our audience developers, I think it's nice to kind of like to bring those two worlds together. So thank you so much for giving us this introduction. I hope that this gives everybody the sort of the curiosity to go explore cybersecurity a little bit more. I would love to bring somebody who is an expert in the field and talk about this. If you guys are interested, maybe we can talk about some of the more, we can go and do some, like, we can explore some vulnerabilities on live sites. I think that would be interesting and scary.
Totally. We're just like, there's a really great DDoS outage map that is live, that is just constantly being updated to show like where things are going down, like where DDoS attacks have happened, which if you don't know what that is, it's essentially when attacker like floods someone's website such that it just gets overwhelmed and just shuts down. And it's wild. Anything that you are developing that is going on the internet, first off, is very vulnerable. Second off, can be used to like take down like governments, right? Like, so if like hackers can use your smart fridge to like initiate a DDoS attack. So this is just something that's really important for developers to like
That's actually
know
really
about.
funny.
Yeah.
You talk about IoTs. I think IoTs are probably the most vulnerable when it comes to cyber attacks. I think that just the team structures that get placed on, like, do we really need a computer on our fridge? And like, I just wonder like what kind of team setup, because actually goes into building the software for like, are you out of milk? And then and now you're whole like, I don't know. But actually, I want to ask you something. I want to ask you how you got into this. Like, what was that initial sort of curiosity that led you down this rabbit hole of like, hey, I want to learn more. And then eventually like, oh, I'd like to teach other people more about this.
Yeah. So I, at the beginning of the pandemic, got this like free ticket to a women in cybersecurity conference. And I was like, yeah, I'm gonna go. Like, I don't know anything about it. And I went and I had no idea what was happening. I went to so many of the talks and I was like, what are you saying? Like, and it was like penetration testing, and like they were showing me like the craziest tools. And so like on the one hand, I was like, this is like really boring. So I didn't understand anything. But on the other hand, like the people that were talking about it were so hyped. Like I've never seen a more stoked group of individuals in tech like talking about it. And I was like, okay, like I feel like there is definitely something here that, I mean, these people aren't just excited like for no reason. I just don't understand any of the vocabulary at all. And so I'm really stubborn too. So then I had the opportunity to work at Fusionoth, and I was like, yes, like I want to know all about this world, like hook me up, like I'm gonna understand. And I mean, like this talk had a lot of jargon in it, but like I was trying to intentionally like make it not very jargony, because when I was learning all this stuff, and I still am, like I have so far to go, it's ridiculous. There's like, you read it and it's all really dry and it's just full of buzzwords and you're like, I have no freaking clue like what's happening. So I'm trying to like make this in like be able to be communicated to other people in such a way that is understandable and not full of like just junk, right? It's not junk, but I mean they have no frame of reference. So that's why I got into like wanting to like teach it. It's just give my best shot at being like, okay, like here's these things as I understand them. And I don't want to just throw like a bunch of like XML and TDOS and XSS and CSRF and JOTS. Like what I wanted to kind of demystify it. It's definitely work in progress, right? Especially when you're talking like just about like I guess the biggest thing that I really want to work on is like understanding how to more effectively communicate. Like here's how to use headers, and how to like just basic stuff like put in this thing in a header, put in this thing in your HTTP request, put this thing in your HTTP response. And it's like, yeah, but if you don't know what an HTTP request response cycle is, like that doesn't mean anything. If you don't know what a header is, it doesn't mean anything. So like as I was writing this talk, I was like realizing like, oh no, like what if people like don't know what that is? So it's just refining it for like your audience and like kind of knowing where people are coming from as well. So
yeah, I love
yeah.
that. I love that. Adeline is asking any advice on where to start to learn about security.
Get a job at a security company. I mean, that's what I did. I was like, I mean, and we're not like a cybersecurity firm, right? We don't do like pen testing and stuff, but I would start just surrounding yourself with people that are in this space, right? Like, so maybe you don't get a job at a company that focuses on like a segment of it, but go to a meetup, right? Like go throw yourself, get a free ticket to a women in cybersecurity conference and just try to figure it out. Another good resource I would use would be OWASP, which, hey, Jacob just posted. Hey, awesome. OWASP is like the MDN of cybersecurity. So MDM is like a really fantastic front-end developer resource. They also have a ton on cybersecurity, which I didn't realize. But yeah, OWASP is fantastic, and they do a good job of explaining things without jargon.
Yeah, absolutely. And I want to add to that where sometimes there might be a cybersecurity person on your team and make friends with them. People love talking about stuff that they're passionate about. So, find people who are in the field and like talking about it, follow them, be like, hey, I noticed that you're talking about this on LinkedIn or on Twitter. Would love to learn more. Get people to talk about things that they enjoy talking about. You'd be surprised how much you can get them to talk about those things.
There's also one thing I'll mention. Since the kind of common consensus is that cybersecurity stuff is really dry, there's a lot of people out there trying to make it really fun. And one of those people is named Ian Murphy. He is on LinkedIn. I'll post his LinkedIn right now. He has all of this content that is like trying to make cybersecurity fun and funny. His most recent one is him like, yeah, he's like trying to, well, he's not trying. He does this thing where he's pretending to be like one of those, I don't know if I can say this on a live stream YouTube.
Does he work for, I can stop the live stream. I think we're done. So I can definitely cut that. All right, guys, if you're watching